Okay, in this mini lesson we are going to talk about the language of functions. So functions is another way of talking about an equation. What makes it different is we're kind of taking it up a level, so we're looking at things a little bit more advanced than what we had done before. And what it is it is a new notation. So instead of seeing y, now what you're going to see are things like f of x. Okay, so we're going to get to that in just a second. In order to really understand what a function is, I have this mini example here that says you're given a problem where you earn $15.75 per hour at your job. So if we want to write this in terms of an equation like we used to do using variables, the one thing that we would remember is that the amount earned would be your y value, and then any number of hours at that job would be that x value. Okay? What that means is we would come up with this equation here, where we have that y is equal to the amount of money I'm going to earn, which is $15.75, times the amount of hours I'm working, which at that point for this problem is unknown. Okay, so that was the equations. Functions simply replace the y value with f of x. And what that says is that we are going to take some value of x and input it in through your system. So right here, this y value here would become f of x. And therefore, my entire equation would change so that I would now have f of x is equal to 1575x. Now, what this tells you is that whatever you have as your x value, you have to input. So whatever this value is inside your parentheses, you have to input it anywhere you see an x. Okay, that's what function says. It's another way of writing. We're essentially telling you what is going on. Now, where things become a little bit more advanced is functions specifically are talking about a relationship between what's called your independent and dependent variables. Well, to do that means you need to know or understand what does independent versus dependent mean. So x is the independent variable because you choose your values of x in order to dictate values of y. We call this one our domain function. Y then is your dependent variable because it is dependent on the values that you get when you plug x into your equation. So the way I like to remember independent versus dependent is like this. My child, whom is 6 years old, is dependent on me to survive. Okay, what I mean is he is dependent on me to give him food, to give him shelter, to dictate the rules that he has to follow, to basically be the one in charge. That makes me, the parent, the independent variable in this relationship, because I am the one who makes up the rules, who provides the food and gives him a place to live. Okay? So your independent dependent variables are just that. X is the one that makes up the rules, whereas your y is dependent. It's the one that has to follow the rules. Okay? So we're going to be asked, or I should say you're going to be asked, to evaluate examples given our new notation. Okay, so the notation again being f of x. The other thing you need to notice or remember is that when we state our examples, most of the time you're going to be given or going to be writing an ordered pair, x comma y. And this is going to really help you when it comes to graphing. And keeping in mind that all of our coordinate points are x, y coordinate values. So we have an example here that says, find f of 3 for f of x equals 9x plus 2. So what does this actually mean? It means if I have f of 3, well, this equals my 9x plus 2. So I have this 3 here, and I need to do something with it. So this 3 value right here has to input into this x value. So what my equation becomes is that I have 9 times my something plus 2. Well, that something in this case was 3. Once you input your x value in, now all you have to do is simplify and solve. 9 times 3 is 27. Still have my plus 2. 27 plus 2 gives you 29. So here, when you're talking about your solution, we are talking about the coordinate pair 3, 29, where x was 3 and y was 29. Okay? Let's look at another. So here I have find f of negative 4 for f of x equals 2 squared minus 3x plus 7. So again, what does that actually mean? Well, it says f of negative 4 is equal to 2x squared minus 3x plus 7. In this case, this negative 4 here has to input not only into my first x term, but it has to input over here into the second x term. So that means I have 2 times something squared minus 3 times something plus 7. That something is my negative 4. So we input the negative 4 into both places, and then all you have to do at this point is reduce and do the math. So here, negative 4 squared is 16. So this is going to be 2 times 16. Negative 3 times a negative 4, negative and negative is positive. 3 times 4 is 12, and then plus 7. 16 times 2 is 32 plus 12 plus 7 gives you 51 as a result. And then, of course, remember your solution could be written as a coordinate point, which would be the point negative 4, 51. So when x is negative 4, my y value becomes 51. Now we can also see it in table form. So here this one says fill in the table. Notice I've given you all of the x values, and in this side I'm giving you the function that you have to plug into. So I'm telling you for all of these x values I want to know their y counterparts. So it's as simple as we need to plug it in. So here we have something cubed minus 4 times my something plus 1. Well, my something in this case is the negative 3. So this negative 3 has to go into the first part, and it has to go into the second part. So this is my negative 3 here and negative 3 here. And now you just simply need to simplify. So we have negative 3 cubed is going to be a negative 27. Negative 4 times negative 3 is that same positive 12 plus 1. It's going to give you an overall result of negative 14. So your solution here was negative 3, negative 14. And you would then be able to graph that point if that's what you were asked. Okay? So let's do it again. You're going to use the same function, but now we're going to change the x value. So here, this becomes something cubed minus 4 times something plus 1. Well, that something in this case, again, is -2. So my -2 gets input everywhere I have that x, and now I simplify. So -2 cubed is going to be -8. -4 times a -2 is +8. These are going to zero themselves out, so +1 leaves you with 1 as an answer. Therefore, we've got the coordinate point -2, 1. Okay. So let's do it again. And this time I'm using a -1. So again, I've got something cubed minus 4 times my something plus 1. That something is -1. When you evaluate at this point, you should come up with 4 as your answer. So please double check my work. And if you notice any mistakes, please let me know. After all, I do believe I'm only human. But that also means my solution now is the point -1, 4. Again, I can repeat the process for each, and now we would plug in the positives. So again, here it would be the same, that I would have 0 cubed minus 4 times my 0 plus 1 gives you 1 as an answer. So here, this is the point 0, 1. Now I have 1 cubed minus 4 times 1 plus 1. When I do that out, you should get -2. Therefore, this would be the point 1, -2. I have 2 cubed minus 4 times 2 plus 1, again gives me 1. So here this would be the point 2, 1. And last but not least, I've got my 3 cubed minus 4 times 3 plus my 1 is going to give me 16, leaving my final solution to be 316. Now you could go on to graph these, and what you would notice is this is a cube function, which means your graph would kind of have that, I like to call it a funky little S shape, where you are ever increasing. But in this case, all we wanted you to do was simply fill in the table. Okay, so now we've seen 2 of them where you work from just an example like these, and you've seen 1 where we fill it in by a table. The other method that we can use with functions a lot is graphing them. So for graphing these, you have to create yourself that XY table in order to graph your functions. Now, the easiest place to start is to create a table that goes from -2 up to +2. That, in general, will give you enough points for you to kind of grasp what it is that you are doing. However, in some cases, you don't have to graph that many points. For example, this first function is a linear function. When we are talking about linear function, you only need 2 points to graph. The reason for that is because this is a linear line, and you only need to have 2 points to graph a straight line. There's going to be no curves or bends or anything like that. So here, when you create your XY table, we're going to choose my X values to input into my Y values in order to find them. The easiest place to start is going to be at 0. Then from there, you kind of just have a choice to make. Now, the smartest thing to do is to be strategic with your point values. So the first thing is I would look at my equation and see if I had any fractions. In this case, I don't. I have only whole numbers, so it doesn't matter what other point I choose. However, I would not suggest being outrageous with your points, meaning you don't need to look at something, say 1,362,000, because that's obviously not going to fit on your tiny little graph here. So you want to make sure that you are using points that are going to kind of fit in the graph that you're trying to create. So don't be crazy. My favorites when I'm dealing with linears is to use points like 0, 1, and 2. Usually they're the easiest points to plug in, and they are the ones that make mental math the easiest math to perform. So I'm going to look at the point 0 and I'm going to look at 1. When I look at 0, again, anywhere I have an x value in my equation, I have to input it. So this becomes -2 times my 0 plus 3. Well, -2 times 0 is 0, plus 3 gives me 3 as an answer. It means I have the coordinate point 0, 3 to work with. Now the next one I have is the point 1. So here, this is -2 times 1 plus 3. -2 times 1 is -2, plus 3 gives you a positive 1 as a result, thus making this the coordinate point 1, 1 to work with. So to come over here into your graph, you need to graph each point individually and then connect the line. So I'm going to start at the point 0, 3. Remember, this horizontal axis is your x-axis. The vertical axis is that y-axis. The point 0, 3 says I'm not going to go over my x's at all, but I am going to go up 3. So 1, 2, 3 puts me right here. And I'm going to go ahead and dot my coordinate. Now my next one is the point 1, 1. So that says I'm going to go over 1, but I'm also going up 1. So that's going to be the point right here. Now I'm going to use a ruler just to let you guys see the line as straight as it can be. However, in most instances you would not be required to have to use a ruler. You just simply have to connect your dots and make it as straight as you can. So you're going to connect those two dots, drawing your lines. Remember, the arrows at the end signify that your line is going on forever, and thus you have completed your problem. Okay. Now the second one is a little bit more in depth. So notice here I have a square, which means my graph is not linear. Instead, it has a parabola shape. So the parabola shape says that you need to have more than just your 2 linear points to graph with. You have to have somewhere between 3 to 5. I like to use 5 points. Okay, so when we're looking at quadratics, we are looking at needing 3 to 5 points in order to graph. Now, as I was saying, I personally like 5, but the biggest thing that you're looking for when you're graphing with your points is you are looking for a change in direction. Okay, so if you think about a parabola, parabolas are either going to go and look like a U shape, okay, meaning they are positive, or they're going to look like an upside down or a frowny face shape. Okay, meaning that they are negative. So the change in direction I'm talking about is right here. It's right where your parabola changes its direction. Okay, so we call this the vertex point. What we are looking for when we are graphing our equations is we are looking for where we changed that direction. So we are looking for your points to either be increasing and all of a sudden start decreasing again, or we are looking for them to start out decreasing and then become increasing again. Okay. So when we deal with parabolas, the first thing that I like to do is I like to look at, okay, is my parabola a positive or is it negative? Well, in this case, I've got this negative out in front. So this negative right here tells me that I have a negative parabola. So with that, with the negative parabola, again, I'm going to choose my x values in order to find and dictate my y values. And I'm going to look at starting out by going from -2 to 2. And what I'm hoping is that within those 5 values, I get that change in direction to occur. So I'm going to look at -2, -1, 0, 1, and 2. And I'm going to hope that at some point I get a change in direction. So when I look at -2, I've got negative of my -2 squared minus 5 times that -2 minus 7. When I simplify all of that, you get -1 as an answer. So now I need to do the same thing. I would take that -1 and plug it in everywhere you have an x, and you would reduce it. And when you do that, you get -3. Do the same thing with your zeros, and you'll come up with -7. Then we input 1, and again, we will reduce it, and we come up with a -13. Lastly, input +2 into your x's, and this gives you a -21. So if you look at all of these points, notice they are forever decreasing in value. Nowhere have I found a change in direction yet. So when that happens, what I like to do is this. I go back to my negative, and I will go one more. So now I'm going to look at -3. And what I'm hoping is that my -3 is going to give me some sign of a change in direction. So I'm going to plug -3 in to my x's and see what happens. Well, in this case, it comes out with a -1. Well, that's actually a good sign, and let me show you why. If I start at -3 and graph it, I'm graphing the coordinate point -3, -1. So I'm going to go over 3, 1, 2, 3, down 1, and it's right here. Now if you look up at the top, I have the point -2, -1. So 1, 2, 1. Okay, it's right here. I'm going to graph in these other points so that you can see what's happening. So I have -1 over 1 down 3, 1, 2, 3. Then I had 0, 7. So 1, 2, 3, 4, 5, 6, 7. And then obviously the others are not going to fit. So if you look, you can see that this side is coming down in kind of like this curved type motion. So that means if I were to test -4, I should get -3 as a result. So if you plug -4 in and check it, what you'll find out is that at -4 you get -3 as a result. So that right here, 1, 2, 3, tells you you have found your parabola, and that your change in direction occurs somewhere between there, and then this one comes down like this. Okay. Now the last thing that can happen when we are talking about functions is we can have word problems, everybody's favorite. So with these word problems, the first thing that you have to do is you are going to have to be able to write the function that you have to use to solve it. Okay, you're not going to be given it. But you are going to be given all the information that you would need in order to solve it. So for example, a computer purchased in 2005 had an initial value of $1,500. If the computer depreciates at $150 per year, write a function in x that represents the depreciation in value. And then what is the value of the computer? So the first thing that we need to note is we have a word here that tells us a lot. Depreciate. Depreciate essentially means that we are going to decrease in value. Now this tells you a lot because this gives you your sign. So what do we know? Well, we know that initially my computer was worth $1,500. We also know that my starting year was the year 2005. I know that I'm depreciating, so I am decreasing by negative $150 per year. So the question wants you to write a function in x that represents that depreciation. Okay? So, what do we know? Well, we know that my function at x is going to be my depreciation, so negative 150. We don't know how many years, but then we have to add in the initial cost of my computer. And thus, that is the function that we had to write. The second part says, what is the value if the computer after 5 years? So the second part says, find f of 5. So we know that says anywhere you have an x, you plug in a 5. So f of 5 is equal to negative 150 times 5 plus my 1,500. So when you solve that down, you come up with $750. Okay? So if you look at it in terms of what my answers had to be, the first answer we have is the equation you had to write, and the second answer you have is the amount of money your computer is valued at after the given time. So there's one thing you need to notice. If you get your function wrong, then you're going to get the second part wrong. So you need to really be sure when you're creating your functions that you are paying close attention to the sign of the problem that you've been given to make sure that you're creating your function in the right way. Now another way that you could see the word problem created is like this one, where it says the cost to rent a car for a day is an initial cost of $42 and then 45 cents per mile driven. Write a function in x that represents the total cost of the car rental. So we have to look at what do we have. Well, again, I have an initial cost which was $42. I am also told that I have a miles cost which is 45 cents per mile. So here I have to write my function. So what do I know? Well, I know that the total of my rental has to equal the cost of my rental plus the miles of my rental, or the miles cost. So here I've got f of x has to be my cost, which was the $42, plus my miles, which was the 45 cents per mile. Well, we don't know how many miles, so that would be x. Now the second part says, what is the total cost if you drive 95 miles? So again, we are being asked to find f of 95, or 95 miles. So here we know f of 95 has to be my cost of 42 plus 45 cents per mile, and I drove 95 of them. When I simplify that out, I come up with an answer that says $84.75. So again, like before, you had a two-part problem where the first part wanted to know the function that you needed to use, and the second part wanted you to evaluate at a certain value. Okay? So this is kind of everything you would need to know in a nutshell for an introductory into functions. If you have any questions or concerns, please be sure to contact me. Otherwise, see you next time.